Hey everyone, we look at calendars every single day, but we almost never stop to think about what they really are. They're these incredible pieces of cultural technology, right? Designed to sync up our lives with the massive, kind of messy clocks of the cosmos. So let's jump right in and explore the amazing story of how we built the very architecture of time. I want to start with a pretty wild thought experiment. Just imagine this for a second. You go to sleep one night, and when you wake up the next morning, 10 entire days have just vanished. Poof, gone from the calendar. It sounds like something straight out of a sci-fi movie, doesn't it? Well, here's the thing. It's not fiction. Back in 1582, for millions of people all across Catholic Europe, this is exactly what happened. 10 days were just surgically removed from history. And the story of why they did that, well, it gets to the very heart of a challenge that has obsessed civilizations for thousands of years. And that challenge, it all boils down to a problem of cosmic math. To put it simply, nature's most important clocks, the rotation of the Earth making a day, the moon's orbit making a month, and the Earth's journey around the sun making a year, they just don't divide into each other cleanly. They're all running at their own pace, and getting them all to line up is the great puzzle behind every calendar ever made. The real source of all the trouble is right here, in that tiny little decimal point. See, the true solar year isn't a neat and tidy 365 days. It's actually about 365 and a quarter days. Well, a little less than a quarter to be precise. 365.24219 days. And that leftover fraction, that little bit of cosmic change, is where all the problems begin. So the first major attempt to wrestle this problem into submission, at least in the West, came from none other than Julius Caesar. His solution, the Julian calendar, was actually pretty brilliant for its time. He just decided to ignore the moon's complicated cycle altogether and focus only on the sun. The system was beautifully simple. You have 3 normal years with 365 days, and then 1 leap year with 366. This averages out to 365.25 days. Simple, effective, almost.
And this chart really shows you the tiny but critical flaw in the plan. You can see that 365.25 is super close, but it's not 365.24219. The Julian year was just a little bit too long, by about 11 minutes and 14 seconds every single year. I mean, it seems like nothing, right? Just a rounding error. Who's going to notice 11 minutes? Well, it turns out those 11 minutes add up. Big time. Over hundreds and hundreds of years, they compound. By the 1500s, that tiny little error had caused the calendar to drift by 10 full days. Now, this wasn't just an inconvenience. It created a massive theological crisis for the Catholic Church, because the date of Easter is calculated based on the spring equinox, and the equinox was showing up earlier and earlier every year. Easter was literally drifting towards winter. So, what do you do? Well, if you're Pope Gregory XIII, you assemble a commission of the brightest minds you can find to literally fix time itself. Their mission was twofold. First, get the calendar back in sync with the sun, and second, create a new system so accurate it would last for millennia. The solution they came up with, mostly thanks to an astronomer named Aloysius Lilius, was just genius. And to understand it, let me ask you a question that you probably think you know the answer to. Was the year 1900 a leap year? Now, your first instinct is probably, of course it was, it's divisible by 4. But you'd actually be wrong. Here's the new, more sophisticated rule they created. It works like a little checklist. Step 1. Is the year divisible by 4? For 1900, yup, it is. So we move on. Step 2. Is it also divisible by 100? Yes, it is. Now, this is where the old Julian calendar stopped. But the new Gregorian rule adds a crucial third step. Unless the year is also divisible by 400, it is not a leap year. And since 1900 is not divisible by 400, it fails that final test. And there you have it. The result, 1900 was just a regular, common year. This clever little trick of skipping the leap year on most century marks means we eliminate 3 leap days every 400 years. This brings the average length of a year incredibly close to the true solar year. In fact, the Gregorian calendar is so accurate, it'll only be off by a single day after 3,300 years. So, with the math finally solved, all that was left was to perform the surgery. The Pope's official decree was blunt and absolute. It literally commanded time to jump forward. Imagine reading that proclamation. Thursday, October 4th, would be followed by Friday, October 15th. Just wow. But as you can see here, this wasn't like flipping a switch for the whole world. You can't just send out a global software update for time. Protestant countries, for instance, were deeply suspicious of a Catholic calendar, so they resisted for centuries. Great Britain and its colonies, including America, didn't switch until 1752. By then, the gap had grown to 11 days. And Russia? They waited all the way until 1918, having to leap ahead a full 13 days to finally catch up.
Okay, so that's the story of the calendar most of us use. But it's so important to remember that this whole let's just focus on the sun approach is not the only way to do things. Not by a long shot. For thousands of years, other amazing civilizations were solving an even more complex puzzle: how to keep both the sun and the moon in harmony.
If you look at India, for example, you don't find one single calendar. You find this incredible, rich diversity of timekeeping systems. The two biggest ones are the Vikram Samvat in the north and the Shaka Samvat in the south. And what's so fascinating is that they have totally different starting points, these eras, reflecting the subcontinent's incredible history. It's like having multiple year ones, all coexisting at the same time. And the diversity gets even cooler, even more granular than that. Check this out. The very definition of what a month is changes depending on where you are. In southern and western India, a month traditionally ends on the new moon, when the sky is dark. But in the north and east, it ends on the bright full moon. This means that even though they're celebrating the same festivals, the start and end of any given month are off by about 2 weeks. It's a completely different rhythm of life.
Now let's travel even further east, because the traditional Chinese calendar is an absolute masterpiece of timekeeping. It's a brilliant hybrid. It uses the moon's phases to define the months, which is great for tracking cycles, but to keep it locked in with the agricultural seasons, it uses this ingenious system to track the sun, called the 24 solar terms. This system is so foundational, so important. It's often called China's fifth great invention.
And these terms aren't like dates on a calendar. They're more like a poetic guide to the farming year. They mark these subtle shifts in the natural world. Insects waken tells you it's finally warm enough for pests to emerge. Grain rain signals the perfect time for planting rice. It's a system that's just deeply connected to the land. So you might be asking, how do these lunisolar calendars fix that drift problem we talked about? Well, their secret weapon is something called an encalatory month. It's basically a 13th leap month that gets cleverly inserted into the year every 2 or 3 years. It works like a reset button, pulling the shorter lunar year back into alignment with the longer solar year, making sure festivals like the Lunar New Year always happen in the right season.
So obviously, these are ancient systems. And you might be wondering, that's cool history, but why is it still relevant today when my phone uses the Gregorian calendar? And the answer is that these calendars serve a different, much more organic purpose. They're not just for business and travel.
And here's what I mean by that. In India today, millions of farmers still rely on a traditional almanac called a Panchang. This thing tells them the most auspicious, the best days for sowing seeds, for irrigating fields, for harvesting their crops, all based on the complex positions of the sun, moon, and planets. It's this beautiful blend of astronomy and ancient wisdom. It's a very similar story in China. The 24 solar terms aren't just a historical curiosity. They still influence modern agricultural policy. They even guide practices in traditional medicine and diet, suggesting what you should eat during certain times of the year to stay in harmony with the changing seasons. So what this all shows us is that we don't really live in a world with just one clock. Sure, the Gregorian calendar might run the global machine of business and international flights, but just beneath that surface, these ancient rhythmic calendars are still there, shaping culture, spirituality, and our deep connection to the natural world. And this brings me to one final thought to leave you with. We often think of standardization as a sign of progress, right? One system for everyone. But when it comes to something as fundamental as time, maybe the coexistence of all these different calendars isn't a problem we need to solve. Maybe it's a profound reflection of our planet's incredible cultural richness. Something to think about. Thanks for joining me.